Hi, I'm Gulderen Yanikkaya Demirel from Yeditepe University in Istanbul. This is where Turkey is located, actually, and this is where my university on the Asian side of Istanbul. We have two hospitals. This is the campus. So just wanted to where I work. So the monocytes are very interesting cells, as you know, and very heterogeneous cells, even though it doesn't look like when you do a blood count. So we know about these cells since 1926, and in the years as the technology develops, as we learn with molecular methods, we have learned more about monocytes. And even though we know the CD14, CD16 subsets immunophenotype analysis since 1980s, we still don't really know what is the normal for population-wise. And the approach to make analysis of these cells, any immune cells, is that you have to know the normal so that you can make an interpretation about the abnormal cells in disease. So health status of the monocytes are very important. And after the 2010, because there was a lot of new molecular technologies, we have learned more about the monocyte subsets. Right now, we think that there are 3, but there are a lot of papers mentioning that there's at least 5 different subtypes of these monocytes. So we have published a paper in 2017 about the analysis of monocytes in clinical cytometry. And as we have stated in that paper, the monocytes, the mature monocytes, have CD33, which all of the monocytic lineage cells carry all along their maturation. And there is many different markers that we can use to describe these different subsets of the monocytes. But the basic monocyte subsets in blood are divided into 3 main groups. There is classical, intermediate, and non-classical cells that we classify according to their expression of CD14 and CD16. And the classical ones are the dominant ones in the blood. They are 85%, and there is no major subpopulations proposed for these cells up to date. The intermediate ones are CD14 positive, how would you say, dim CD16 positive. They make 55% of the cells, and there are some, by sequencing, there's 2 further subpopulations that are suggested. And non-classical ones are the ones that doesn't carry any CD14 or low, and they are expressing high amount of CD16, and they make 10% of the monocytes. And again, with different type of gene analysis studies, there are different type of descriptions, expressions, but we know that some molecular analyses have different changing, diverse, how would you say, sensitivity and specificity. So there are different ideas about this. But there is some papers reporting the subpopulations according to SLAN expression on these cells. What we see in the flow cytometry when we look, we see the classical ones, CD14 ones here, the intermediate ones are here. These are the non-classical monocytes. And they have, up to, how would you say, 10, 15 years ago, we only thought that the monocytes' main function was just antigen presentation. But the new knowledge in immunology, we have learned that they they have a role in trained immunity. They increase the monocyte production, increase cytokine production, and stimulate bone marrow to produce more monocytes when there are any type of inflammation, cancer, or a disease. So they are, especially after inflammation, they come to action very quickly. There is, of course, some different type of monocytes that are not really into classification now, but there are neutrophil-like monocytes that act like neutrophils. There is papers about this. There is they are very helpful for tissue repair. There are tissue-resident macrophages, like the cardiac macrophages that have been there from the development period of the human body, and they do a lot of patrolling, just like the neutrophils, so that they maintain the vessel integrity, and when there is necessity for inflammation, they go into the inflamed area. And there is a monocyte reservoir. So in the spleen is the largest reservoir for monocytes, and they rapidly deploy from the organs that they are deposited when there is an inflammation. So there is, and I must remind you that most of this information comes from the animal studies. There's a lot of animal studies that are done with the monocytes, but human monocytes may act differently than the animal ones. And of course, these three different subsets, they are not how would you say, only expressing CD14 and 16. They do express different type of markers. With these, we won't be able to go into these markers, but they have different functions also. Like the CD14 positive classical ones have high phagocytosis potential. They produce a lot of antimicrobial agents. They have strong interactions with platelets, and after the stimulation, they produce different type of molecules. The intermediate ones, they are mostly doing MHC processing and presentation. They stimulate the CD4 positive T cell proliferation, and they have pro-angiogenic capacity, just like the non-classical cells. So these non-classical cells have high basal reactive oxygen species production. They are working more for viral infections, and they mobilize from the marginal pools by exercise and activity. So,
actually, 1 minute. Yeah.
Sorry?
1 minute left for you, right?
1 minute. Okay, I will go very quickly. Then, what we do with the monocytes, we have monocyte immunophenotype analysis from healthy donors. We have functional analysis, phagocytosis, cytokine measurements. We did a lot of work on HLA-DR on monocytes, especially in sepsis patients. And we collect data from these patients and healthy people. So we use these markers for this study. This is what we have obtained from the bronchoalveolar lavage fluids in a COVID-19 patient. As you can see, the classical monocytes are increased. Because this is a severe patient, there is almost very small number of non-classical ones. And this is interesting because we have collected samples from people with anosmia patients in COVID-19. And as you can see, they all have different type of patterns that gives clue about two different populations of the CD14 intermediate donors. So due to heterogeneity, there is more need for more number of samples because 200 samples is not enough. There is standardization of analysis, validated reagents are important. The collaboration with molecular studies will enrich the monocyte database that we have, and we would like to have comparison analysis with different laboratories so that we really know that we do a standardized work and collect data. So this is all from me.
Okay, thank you. Yeah, I'm sorry to squeeze that your talk, sorry. So, and there's a very interesting, yeah.
Kind of ran at the end.
So, actually, did you also analyze that characters of those monocytes found in the COVID-19 patient? Any the functional or phenotypic the correlation with your anosmia patient COVID-19? Any functional?
Yes, we have all of the clinical data for those anosmia patients, and most of those patients, we have around 40, 45 patients. They are all medical residents that are in between age of 25 to 27. And each and every person has a, how would you say, different signature of monocytes. So no one has, and all of the samples were taken at the day of diagnosis, on the day of diagnosis.
Is that from the nasal swab or from peripheral blood? Is that
peripheral blood?
Peripheral blood. Peripheral
blood, but we have samples, bronchoalveolar lavage fluid samples from 4 patients. Unfortunately, that's so low, but we have taken in time. So 0 day, 3 day, 7 day, and none of them lived up to 21 days. So we could not collect any samples in that time.
Okay. Thank you for your talk. So maybe we can ask audience to upload your questions to our Q&A panel. So maybe you can, or maybe you can, in the end of the session, maybe you can also ask your presentation too.
Okay.
Thank you, Dr. Demirel. So
thank you.
Okay, please indeed, yeah,